Good to see you. Thanks for joining us. Let me go ahead and read the introduction for Jordan here.
Sure.
So Jordan is a quality assurance engineer at NASA Jet Propulsion Laboratory. He graduated from Cal Poly San Luis Obispo with an MS in industrial engineering and a BS in industrial technology, and a minors in computer science and in packaging. He was like your basic sort of overachiever guy in school, right? So while in grad school, he produced a thesis in operations research and was a member of the Cal Poly CubeSat Labs ATLO team. He's currently at JPL, Johnson Propulsion Labs. He facilitates hardware delivery reviews for the Europa Clipper mission to Jupiter and leads process improvement efforts. He previously helped align QA with the unique needs of higher risk tolerance projects, worked on the FDA authorization for JPL's COVID-19 emergency ventilator design, and inspected hardware for the Mars 2020 Perseverance rover. So thank you, Jordan, for being here.
Oh, always happy to come back, Dr. Olsen.
Yeah. No, Jordan, it's really good to see you. You know, you sort of tipped me off that you had sort of just finished your black belt certification with JPL after getting your green belt here with me here at Cal Poly. So I'm sure you actually had to do, harder things, in that process. But
I will say, you taught me the important distinction between black belt trained and black belt certified. I am currently black belt trained. I have not done the two projects that they're going to require just yet, because each one's going to take me about a year.
Yeah, you're going to be in it for a while. So
yeah.
So Jordan, I'm trying to think of like how best to do this. I know when we've talked in the past, you've got a lot of really cool stuff that you've been doing. But maybe you tell us a little bit about your job and feature some of those highlight things that you mentioned that I mentioned in your bio, so students can see what's the possibility for them going into the real world here.
Yeah, for sure. So I was in this major. I was in industrial technology. At the time it was called industrial technology. It was renamed to ITP after me, which is why I was able to sneak in the packaging minor at the time. But I was I started at Cal Poly in 2013, so not that long ago. And I did the very classic ITP thing of having no idea what I wanted to do, and then going off in a direction that no one expected, which is what I think 95% of ITP people do, right? So, I now am a NASA engineer with a degree from a college of business. Which is insane to anyone who isn't an ITP major, because realistically what I do in my job today is all the stuff I learned at Cal Poly, all the stuff I learned in Orphalab and in my master's as well, reinforcing it, but a lot of it I learned from Dr. Olsen, for example. So I was originally hired as effectively a process improvement person, but the idea was that I had a mixture of skills. So I use my business skills every day because I am now very good at doing presentations and sales pitches for ideas to my management and how to actually go do market research and stuff like that. It's a nonprofit, it's NASA, right? But I still am trying to figure out what my target audience is for things, and then figuring out how to go interview them and gather information and things like that. I use that all the time. I use the manufacturing knowledge all the time because I'm a quality assurance person and we're building spacecraft. I was a political science TA, and I'm here writing rules documents, and all the engineers think they're lawyers. So I'm using that all the time too. And it just all feeds together.
Yeah. So Jordan, it occurs to me, I think you just sort of caught the tail end where people are doing their mini projects. And one of the ways we think about it is, telling a story. So when you're sort of, sales pitches and working on projects, is storytelling a thing at JPL and NASA?
It has to be. Yeah, no, it's in every single part of our DNA, right? So I don't know if I said right. Yes, it's in every part of our DNA. So everything from, it is a core part of NASA's charter to do outreach, public education, inspiration. That's why I'm getting paid to be here right now. Hi. It's why JPL has won multiple Emmys for our outreach. It goes down through when you're building a spacecraft. So for context, JPL, the NASA center that I work at, specializes in deep space robots. It specializes in all the robotic exploration that we can't or are not yet able to send humans to. So that's everything from Mars rovers to the Jupiter orbiter I work on, to Earth science, climate change, satellites, all above. And so we are heavily driven by science. We're trying to explore the universe around us. And so every spacecraft we send is to try to answer some questions. In order to answer new questions each time, you have to send new tools each time. And so every spacecraft is unique. And so when you're building these spacecraft, every single one, you're basically flying a prototype. And so storytelling is actually a big part of the manufacturing and design process, because you have to get a whole bunch of expert engineers in a room together to agree that what you're planning is actually going to work well. And so you have to walk them through, here's the problem we have, here's why I think this design will work, here's how the design will work, here's the problems it will have that we'll have to deal with as a part of it, and all the way through it. And then when things break, because they always break, because it's things that are new, you then have to figure out, okay, here's the possibilities of what could have happened. And you convince yourself of the various stories of what the possible options are, and then you chase it down from there. Or when I'm like working on a process improvement effort, I have to tell the story of here's why this is useful when I'm selling my idea. Stories are everywhere.
Interesting. So Jordan, I'm just trying to think of, like, could you give us sort of an example of, maybe your current hot project or something that, you were sort of involved in? I know you're jumping up and down because something landed on some other planet that you had a hand in, the last time.
Yes. Yeah. So that one was, I had a little bit of a hand in the Perseverance Mars rover. And it's kind of an amazing thing as a kid with a business degree, an ITP degree, to be able to say that I've held things in my hands that are now on the surface of another planet. That's not something I ever expected to be able to say. And so now I'm working on Europa Clipper, which is our next Jupiter orbiter. So it's going to this, right behind me is this big, beautiful moon named Europa that's orbiting, that's this moon of Jupiter. And we think it has a gigantic ocean underneath this thick ice crust. And one of the core parts of NASA's charter is to understand, are we alone in the universe? And so all life that we know of on Earth requires water to live. So a gigantic liquid saltwater ocean seems like a good place to start looking. And so my gigantic, expensive, highly complicated, very intense spacecraft is going to be going, I say me and 1,000 of my closest friends, right? Our spacecraft is going to Europa in several years to actually try to learn more about this place and see whether it could possibly be a place that hosts life. And so I am involved with, I call it the hardware delivery reviews, but basically I help run these reviews where we certify every single piece of hardware on this entire spacecraft to make sure that everything's actually done, it's all ready to go, before we put it together and then launch it to space. Because once you put it together, it's kind of a pain to take it back apart again.
Exactly. Hey, Jordan, I want to encourage our students, if they've got a question for you, to go ahead and type them in the chat. There's very few things that you can't address or answer. I've had great experience with you. By the way, Jordan, I just want to say, we're doing a hobnob at my house on Friday, in case you want to drive up and hang out in the late afternoon or something.
Good to know.
Yeah, good to know. So yeah, if you got a question for Jordan, go ahead and type it in the chat, and we'll have you jump on and speak to him directly. One thing, kind of back to the story thing is, we're teaching the students, the DMAIC, problem solving process, and it's also, what you just, I guess got trained on again, in your black belt thing. How much is that sort of in the water at JPL, or is everybody sort of familiar? Is that walking around knowledge, or do you have to educate people as you go through?
So DMAIC specifically does not have as much traction as I would hope. We're constantly trying to teach more people, but we have a lot of variations on that theme. So it is core to how we do aerospace at NASA, that we have effectively a define, design, analyze process for how we build spacecraft. We call that like the the phase A down to the preliminary design review, critical design review, that kind of stuff. Like, so people don't use the phrase DMAIC, but the idea behind define the situation, define your goal and what have you. Then let's do trade studies on different ways to handle it. Then let's actually analyze whether it'll work in the right way, and then we go make it. That concept is embedded in everything. People just don't realize that what they're talking about is DMAIC a lot of the time.
Exactly. So, so do you have like a story for us about something that worked really well, or maybe not, something else that didn't work quite so well and you learned from in your?
Yeah. So one of the lessons that I've learned recently is how critical understanding your champion and sponsor and the makeup of the team is. And specifically, not having the sponsor be on the team. The sponsor is a critical component. You will not go anywhere if you do not have someone sponsoring your idea. But if you have the sponsor get into the weeds with you, because they are a person who has a lot of authority and a lot of credibility, that's why they're able to be your sponsor. They inevitably just start taking control of things. And they have a very important role sponsoring the idea. They are not, however, the best at actually trying to figure out how to work through the DMAIC process. That's why they hire me. And so we've had a couple times where the sponsor wanted to get involved, and I was not able to prevent it. And surprise, the effort stalled out because they took it off in a very
weird,
unproductive direction. And it started producing poor work product, is straying from the DMAIC process and all that. And surprise, now I'm going to have to go back in to do cleanup. Now that I've gotten them to forget about it for a while, I'm going to have to go through and do it all myself and then bring it back to them and say, hey, look at this thing I have for you to review. Yeah. And so if we had just started from the beginning of making it clear, your role is sponsor, my role is DMAIC, and both of us embracing our specific roles very effectively instead of trying to cross it apart, we would have already been done.
It's interesting too, because I think, we all develop some expertise in certain sort of areas, and maybe we get to that level of the organization where we can have a really sort of strong influence, but just because you can doesn't always mean that you should, right?
Bingo.
So
yeah, and he has sorry, I mean, obviously this is a specific example, right? But like the person I was working with, he had very specific strengths that I critically needed. He had an incredible amount of knowledge that I did not have. He's 40 years older than me. He's been doing QA that entire time at JPL. But I needed to leverage him for those things. His strength was not how to write a Word document. And so when it starts going into those things, now I have to go undo a whole bunch of work. And so it's always being a matter of recognizing what your strength is and what your weakness is. I would not try to go talk to a whole bunch of high-level people to sell this idea. I want him to do it because he will do it way better than I will. And I have no shame in that. And vice versa. He shouldn't be trying to write up the Word document for me. I should be doing it because he's not going to be doing it as well as I am. We have our own strengths.
Yeah, interesting. All right. Well, do we have a question or two for Jordan here at this point? So
at some point, I should also probably talk about how lean works at JPL. if anyone has a question first, though.
Yeah, there you go. What do we got? Who's got a question? I think Jordan, you overwhelmed them a little bit. So
I do that. So so lean at JPL is funky. So like I mentioned, every single spacecraft we build is unique. And I remember when I was in Dr. Olsen's class, I learned about how you're going to be doing these value stream maps so that you can get that 1,000,000 cans a day through the Pepsi factory or whatever it was. And it's very strange when you get to an environment where not just we only build things once, we're still designing it while we're building it, and vice versa. Literally, as we're building a computer, like a specific circuit board that we're using in one of our avionics boxes, for example, it can enter the electronic fabrication shop where the drawing is at revision C, and it can leave their electronic fabrication shop fully built where the drawing is now at revision H. That happens. And you have to maintain the configuration of that whole flow. And how do you do lean when it's changing while you're designing it and you're only ever making that one? And so for a while, I think you probably remember the past several times I did this, I kept saying like lean half applies at JPL. It applies in some ways and not in others. And what really matters is the mindset. I'm really thankful that I went to go through this black belt training and specifically by a JPL instructor, not because I didn't get a lot of value getting it from a different instructor at Cal Poly. I'm actually really glad I've done both now because I want to see different views. But it was really great seeing someone who was in the JPL context teaching it to me because he went, oh, no, 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 no. Here's how that's all wrong. And actually, here's how lean applies in this way, and this way, and this way, and this way. And it turns out I just was framing the issue wrong. And that was really eye-opening. And so, yes, in that case, that one unit, of course, I can't figure out how to develop that one in a specific way very efficiently. Like it's changing while we're building it. What are you going to do? But we do 100 a month that are changing while we're building it. So our process for how we manage those configuration changes, for how we manage it flowing through as it's changing, and our estimation and forecasting and all of that, that we can do. And we can actually pull data to go do that. And we can be doing those very strict measurement steps. You just have to expand your scope of how you look at the problem.
Yeah, we kind of swim in a sea of processes, and as long as we're sort of seeing the process, as opposed to seeing that sort of individual unit, you can kind of see where the process tends to repeat, right? So like even the simple thing like ideation or problem solving, or how many problems do you solve a day at NASA? I don't know. That's a question.
I don't even know how you quantify that.
So it's interesting. All right.
Yeah.
Well, Jordan, as I said before, we're trying to keep these a little bit sort of tighter so that they're not a 40-minute recording, but they're a nice good 20 minutes or so. And we can kind of put this up on YouTube if that's okay with you.
There is a
Sure.
question.
Yeah.
Oh,
and I think
we
there's
do
one
have a
question.
question. Okay. So
Yeah.
whose question is it, Lauren?
Cameron.
Who is it?
Cameron.
Cameron, you want to jump on here and ask a question?
Sure. So do you have a favorite project that you've done at your job, where you think lean has come into play that's helped you within that project?
Yeah. So I think lean comes into play in everything. It's just a matter of whether you're using the formal language or not. The biggest thing that I took away from my lean training was the mindsets. It was the idea of looking at processes, the idea of you can make things more efficient, the idea of you should act upon data, things like that. All the stuff that Dr. Olsen's been drilling into your heads, they're all really useful. I don't use the word Buddha. I don't actually draw value stream maps as often. Like I don't do that, but the mindset I use constantly in every facet. And so specific projects where lean came into play, I actually haven't, the projects I'm working on right now, I haven't had to do DMAIC for it. That's why my black belt project is still needs to happen later. But what I have done is I'm constantly looking at the process overall. So for example, right now I'm working on all these hardware delivery reviews, I called it, for Europa Clipper for this Jupiter mission, where we're certifying every piece of hardware that goes in the spacecraft. That means I've now held like 163-hour-long reviews in the past 2.5 years.
Wow.
And that's obviously very time consuming because every one of those reviews has dozens and dozens of highly paid people. And so I have gone in and we've redesigned a whole bunch of things just to make things clearer. Because I started doing basically effectively like the problem check sheets, right? Where I was like tally every time something going wrong. I was doing it constantly, so I knew what all the problems were because I was the point of contact on it. And even though I didn't literally use the tool, I knew that mindset. And so when I went through it, I was like, yes, we're wasting our time on every single time. And so, one night I spent a few hours redesigning this Excel sheet to be a Word document. And that Word document has now saved probably hundreds of man hours on this project. Just because Excel was hard to use in this one context. A simple change like that has a really big impact. So I have not had the fortune of being on a strict lean project at JPL yet. I hope to do that in a year or so. But the concepts from it, the ideas behind it, the intent behind it, I use constantly, and it already has a big impact in every single job I've ever done.
Thank you, Jordan. I think we have another question. Alyssa, why don't you jump in there and ask a question, please?
Okay, let me read it. Let me pull up the chat. Okay, so even though you've worked at JPL, I don't know if you know how other defense or space companies use lean in comparison to NASA, or like if you could like shed some light on that, that would be cool.
Yeah, so JPL is, I think, unique in how little we use it. JPL is a very special NASA center. It's structured differently from the others. I won't bore you with what an FFRDC is and all of that. But what it basically comes down to is JPL does things once. The rest of NASA does things over and over, and all the aerospace companies do things over and over and over and over. So you know how I was given that example of how, it's really difficult for us to, it was difficult for us to apply lean because the circuit board changes so many times during it. But if we take a step back, it's easy to see how we could deal with it in these ways. It'll just be a little bit funky. At the other places, it's not hard to picture at all. The same space shuttle design launched 135 times. The various like communications companies build the same communication satellite over and over and over again, very intentionally. SpaceX does the same rocket launches over and over and over again. They improve it every time, but it's the same type of product happening over and over again. It's not vastly different like a lot of ours are. So actually, so like SpaceX, Lockheed Martin, Northrop Grumman, I'm sure I'm forgetting some other ones, and this is going to go on YouTube and I'll get in trouble, but like all the big aerospace companies use an incredible amount of lean. They have very strict structures around it. They have very strict programs in place. They take it very seriously. NASA does a lot trying to do that as well when they're building like the SLS rocket and stuff like that. JPL is more loosey-goosey than some of the other ones just because we build everything uniquely. And so we are using it more and more. We are constantly striving to improve. That's why I was hired, right? Like it's not like I came up with the idea of doing this, but it's implemented differently for us because we are a bunch of one-offs over and over again, whereas the other companies tend to repeat things a lot more.
So thank you, Jordan. Alyssa, did you have like a specific company you want some insight on?
Oh, I mean, like I interned at Northrop, so like that's why I asked. But like, yeah, thank you.
Yeah,
Sure.
it sounded like, thank you. It sounded like you had a little bit of direct experience. So yeah, they're all, it's interesting the sort of the range and different sort of approaches all the different organizations in a very similar industry, take. Jordan, I'm gonna have to kind of put a cap on it here, but thank you so much once again for jumping in. I'm glad you're getting paid for this. I'm getting paid too. These people out here are paying, so just we have the relationship set up. But Jordan, how we always end these interviews. If you had one piece of advice to give to this next generation of lean leaders and soon or future Cal Poly graduates, what piece of advice would you give to them?
Yeah, since I'm probably the speaker who does lean the least formally out of the other ones, just because my job's a little bit different, the advice that I will leave you with is something I was hinting at earlier. I'm going to guess that at least half, probably most of you, are not going to go into a formal lean job, maybe won't even go into manufacturing things at all. And so the thing that I would love for you to walk away with is that this applies everywhere. It applies in everything, and it does not have to be done in this very strict formal manner with Japanese words for it to be useful. It's very helpful when you think through a problem beforehand. You define before you measure, before you analyze. You should do that. But whether you literally call that DMAIC, whether you literally draft up a project charter, or you just do it, you just go implement it right away, the ideas behind it, the mindset behind it of trying to improve, defining the problem beforehand, of actually using data, that will be applicable in everything: accounting, law, healthcare, you name it. Like there's nothing that this does not apply to in some way, even if you're not using the Japanese words.
All right, Jordan. Well, Jordan, thank you very much. To say thank you a little bit differently or more formally, we're going to ask everybody to pop on their video. Go ahead and, Jordan, if you switch over to the gallery view, kind of see some of the lives that you're affecting. And I'm going to go get the camera, and so you can see the people in this room too. There they are. Everybody give Jordan a little wave and a thank you. There you go, Jordan. So
fantastic.
Good. All right. Take care of yourself, Jordan, and hopefully we'll see you in San Luis Obispo sometime soon.
Yeah, that'd be great. Good to talk to you guys.
All right. Take care, Jordan.